Has anyone gotten an answer yet? You can type it in the chat if you do. Okay, well, for this one, we can let the variable x be the total number of votes. And we know that 65% of the votes were like votes. So 0.65x would be the number of votes that were likes. And at the same time, if 65% of the votes are likes, then 0.35, the other 35% must be dislikes. So that means 0.35x of the votes are dislikes. And since each dislike votes decreases the score by 1, 0.65x minus 0.35x will just give the score. And we know that it's 90. So this is 0.3x in total. It's 90. And if we solve the equation, we get x equals 300. So there were 300 total votes cast on his video. Anyone have any questions about that, or can we move on? Okay, so here's another checkpoint. You can try this one on your own, and then we'll talk about it in a minute. Okay, does anyone have an answer for this?
if you don't have any answers, do you have any progress that you can maybe show, like like equations?
Okay, so I think we'll use two variables for this one. M is the cost of the movie ticket, and S is the cost of his soda. So yeah, 23 out of 99. And it's the AMC, so it wants the nearest whole percent. But yeah, that's correct. So the cost of his movie ticket was 20% of the difference between A and the cost of his soda. So that means M is 20% of the difference between A minus S. And on the other hand, his soda was 5% of the difference between A and the cost of his movie ticket. So S equals 0.05 A minus M. So if we expand this one, it's M equals 0.2A minus 0.2S. And this one is S equals 0.05 A minus 0.05 M. So now this is a system of equations, and I guess let's use substitution to solve this. So M equals 0.2A minus 0.2, 0.05A minus 0.05M, and M equals 0.2A minus so yeah, because I'm running out of space. You know. Okay, so keep going. We got 0.19A equals 0.99M. So M is 19 over 99 of A. And we can plug this back in to find what S is in terms of A. So S is okay, yikes, I'm out of space. Let's see. Oh, yeah, sorry, 0 plus 0.01. Okay, actually, I'm not gonna finish the problem because we're running out of space. But yeah, it's just a system of equations, and um, the just getting started is like choosing the variables, and then it's pretty straightforward. Why is this the same example? Okay. So going back to the mixture problems, here's another checkpoint along those lines. So try this on your own, and we'll talk about it in a minute. Okay. Does anyone have an answer? 2%. Okay. So for this one, um, the pitcher starts with 4 cups of water and it ends with 9 cups. So that means we added 5 cups of salt water. So now let's let X be the concentration of those 5 cups. And when it ends as 9 cups of 40% salt water, so that means that there will be 9 times 0.40 of salt at the end. And when we started, when we added the X percent salt water, we added in 5 times X of salt. So that means that we have this equation for X, and if we solve for X, we get 0.72. So the concentration of the saltwater solution is 72%. Okay. So now let's talk about work problems. So there are lumberjacks that need to cut trees, and assume they all cut the trees the same way and there's no interference. So one day the 20 lumberjacks cut down 100 trees in 60 minutes, and the problem wants you to find how long it would take for 50 lumberjacks to cut down 50 trees. So if we start to look at it, we're 20 lumberjacks, 100 trees, and it's 60 minutes. Sorry, my handwriting is not good. but we increased the number of lumberjacks from 20 to 50, and that's an increase by 5/2. So that means that the amount of time it will take will also be reduced by the reciprocal of this amount. So 1/5/2. And then, yeah, at the same time, we also reduce the number of trees that they have to cut down from 100 to only half that amount, 50 trees. So first we're multiplying the time by the reciprocal of 5/2, and then we're multiplying by 1/2. So that would be, I forgot the 60. 60 times 2/5 times 1/2 equals 60/5 is 12 minutes. So there's not a checkpoint for this. So in general, there's an equation we can use to make these kinds of problems more simple. So let's say work is the workers, W is the number of workers. And T is the amount of time it takes to do the job. And S is the size. So let's say worker W1 is like the first number of workers times T1 is like amount of time for the first group, and divided by S1. This ratio will still be true for W2 times T2 over S2 for like a different set of workers. So let's say we had I'll just come up with a small example right now. Let's say we had 6 farmers feeding 6 chickens in 6 minutes. How long would it take for 3 farmers to feed 12 chickens? Does anyone have the answer real quick? Yeah, I think 24 looks good because, so first 6 times 6/6 is on this side, and then we don't know what time 2 is, but there are 3 farmers and 12 chickens. So if we solve this, we get the time is 24 minutes. So another kind of work problem is that often comes up is there are various numbers of people that are doing the same task, but they work at different rates. So for example, Reimu is, someone is in the waiting room. So Reimu takes 20 minutes to mow the lawn alone, and if Reimu and Marissa work together, it takes 50 minutes for them to do it. So so the way to tackle this is for Reimu. Each minute she completes 1/20th of the problem. And then for Reimu and Marissa working together, each minute they finish 1/15 of the problems. So let's say Marissa takes n minutes to mow the lawn if she works alone. That means in 1 minute, she can do 1/m of the lawn. So if they're working together, that means each minute, Reimu and Marissa can do 1/20 plus 1/m of the lawn. And that has to be the same as 1/15. So if we solve this out, so we can multiply both sides by 60. So 60 times 1/20 is 3. And this actually might not work that well, but whatever. And times 60 is 4. And so that means 60/m equals 1, and m equals 60. So 60 is correct. Okay, I think we have a checkpoint. Or not, never mind. Okay, so something similar to work problems is distance, speed, time problems. And the main equations involved are just the distance equals speed times time, or time equals distance over speed, or speed equals distance over time. And another one that I guess isn't as commonly seen is the average speed. The speed average is equal to the distance total over the time total. And then for each, if your trip is like split up into different legs, the first leg being D1, and then the next leg being like D2, and so on until DK. Then it's similar. It's the sum of all that over the sum of all the times it takes for each part of the journey. And it's the same since t is equal to distance over s. We can also write this just in terms of d and s. So d1 over s1 plus d2 over s2 plus d3 over s3. And this is useful in problems where they only ask you for the where they only give you the distance and the speed. Okay, so let's take a look at this problem. So in the road trip, Kylie first drove at 60 miles per hour for the first 90 minutes, 40 miles per hour for the next 60 minutes, and covered the last 100 miles of her trip in 50 minutes. So we see the word like speed, and we immediately think to use distance equals speed times time. So, and also we're trying to find the average speed. So we know that is S equals D over T. Okay, so let's look at the first section. She drove at 60 miles per hour for the first 90 minutes. So that means she drove 60 times 1.5 miles in 1.5 hours. And then next she drove 40 miles per hour for the next 60 miles. And so she went 60 miles, and the time it took to do that was 60 over 40. And then finally, she traveled 100 miles in 50 minutes. So 100 over 50. And if we do all of this out, it should come out to, let's see, 90 plus 60 plus 100 over 1.5 times 1.5 plus, oh, and this is 50 over 60 hours. So the total distance is 250, and the total time is 19 over 6. So overall, the average speed. Actually, I think I did something wrong. Okay, someone can double check my math. But yeah, that's the gist of it. Okay. So let's take a look at this checkpoint. Okay, does anyone have an answer? Yeah, I think 67 is correct. So, let's say Sam drives 96 miles in 90 minutes. And we're trying to find the average speed during the last 30 minutes. So we know that he has to drive 96 miles. In the first 30 minutes, he will drive 30 minutes times 60 miles per hour. So 30 minutes is half an hour times 60 equals 30 miles. So first he drives 30 miles, and then during the second 30 minutes, he drives 65 miles per hour. So in that stretch of time, he drives 0.5 times 65 equals 32.5 miles. So that means there's he's already gone 62.5 miles, and that means there's 37. No, that's not right. 33.5 miles remaining to cover in the last 30 minutes. So thinking back to distance equals speed times time, 33.5 equals speed times 0.5, and speed will be 67. So his average speed would have been 67 miles per hour. Okay. So another kind of problem that involves distance and speed and can also seem kind of tricky is something like this. So let's say Kevin and I live in houses 90 miles apart, and we both leave our houses and drive to the other person's house along a straight line. And Kevin is driving at 75 miles per hour, and I'm driving at 60 miles per hour. Because, and then how long after they start driving do they cross paths? So, so we're 90 miles apart, and every okay, so we'll go by each minute, and every minute that I travel, so that's like 1/60 of an hour, I will go 1 mile. But every minute that Kevin travels, 1/60 times 75, he will travel 1.2 miles. So every minute, we both narrow the gap by 2.25 miles. And when the gap becomes 0, that means we've like kept on moving together in 2.25 increments until we've covered the whole 90-mile distance. So that will happen when we do 2.25 90 over 2.25 times, and that is equal to 40. So it takes 40 minutes for the gap between us to become 0. And to find the point where we meet, so we can take the 40 minutes, which is 2/3 of an hour, and I'm traveling at 60 miles per hour. So that means I will have traveled 40 miles from my house, and Kevin will have traveled 50 miles from his house. Okay, this is an example, but try to look at it first, and it has a little twist. See, and we'll talk about it in a minute. Okay, 50 looks correct. So, um, so to start with this, the distance that the fly travels is distance equals speed times time. Right, so if we actually find the amount of time the fly travels, we know the fly travels at 30 miles per hour. Um, we know the fly travels at 30 miles per hour, so we can find the distance that the fly travels in total that way. So the amount of time that the fly is moving is actually the amount of time that it takes for the car to reach B. And we can compute that because we know the distance from A to B and the speed of the car. So the speed of the car is 60 and it has to travel 100 miles. So that means the car takes 100 over 60 um, hours to get to B. And that means it also means the fly is flying for 100 over 60 hours. So the distance that the fly travels is 30 miles per hour times the time, 100 over 60, and that is 50 miles. The There maybe there's a slight problem with the problem because the fly is wait, never mind. Okay. So we're going to almost do Kahoot now, but before we start, we were actually planning on covering statistics, but things took a little bit more time than we intended. There's going to be a few statistics problems in the Kahoot, but there'll just be the basic things like the mean, which is the sum divided by the total number of values in a collection of values. For median, it's the middle number out of all the numbers. So for 2, 5, 8, 10, 11, the middle number is 18. And the mode is the number that occurs the most often. So for in this one, for example, 3 occurs 3 times, so the mode would be 3. And the range is just the difference between the greatest and least values of the set. Okay, so I'll set up the Kahoot now.
Is that everyone?
Okay, what about now? Okay, can we start? Oh, okay, there we go.
That's everyone. You shall start.
Let's go. Can you guys see the problem?
It works for me. Try yeah, you can zoom. Yeah, that works. Okay. Do you guys want to go over this one or no? Oh, someone can't see it. It's like your screen blank for you, or is it just like you cannot read it?
Thanks.
Oh, maybe, huh? It's probably an internet issue then, but I don't know how can we fix that.
Okay, maybe the next one will be better if it's full screen. Congrats to Lillian for leading. Oh no, sorry.
Ooh.
Okay,
So
nice.
something I noticed, can you back to the problem? So something I noticed was that a lot of people put down 6, and I can probably see why is that because in the given set there are already 2 6s, so it might be logical to think that you can use 6 because it means it would fit the median in the unique mode. However, that doesn't mean the mean would be 6. The mean, if you set 3, 4, 5, 6, 6, 6, 7, is going to be below 6. So what you would have to actually do instead is try to calculate uh, the mean and set that to the unique mode, which would probably be 6, and that would get you to 11.
Yeah, so always double check to see if your answer makes sense.
Oh, I mean, fit the criteria.
All right. Lillian is still in the lead. Okay. Um, so any questions about this one? It's just like another word problem where assigning variables might be the first step. All right. Lillian is still in the lead. Okay. Any questions about this one? Oh, let's move on. People coming into the leaderboard. And there's no music anymore. Okay, any questions about this one? Kind of just have to do some multiplication. Actually, if you want a fast way to do 181 times 101, you can split it into 180 plus 1 times 100 plus 1. And that way, all you basically do is do like binomial multiplication, and then it's 180 plus 100 plus 1, which is 281. So that might be a faster way to do it. Okay, no change. Okay, any questions about this one?
I'm just kind of curious. For those who put down 20, how did you solve it?
All right, does someone want to like explain their approach to solving the problem? You can do it through the group chat if you want. Um, okay, if not, um, the thing is with median, Amanda has 4 cousins, which is an even number. So the median age is like the average between the like 2 middle um, numbers. So that means if it's the average, the sum of the 2 middle numbers would be 5 times 2 equals 10. And we know that in total, all the ages add up to 32. So the sum of just the youngest and the oldest is 32 minus 10 equals 22. All right, let's move on. Still no change. Okay. Any questions about this one? Okay, we'll move on. Then. Catherine takes the lead. All right, great. Um, any questions about this one? Hmm. Okay.
Mm.
So maybe we should talk about this one. What variables did you guys use? TFQ. So like one for each type of coin. Since we know that in total there's 23 coins and oh sorry. There's 23 coins in total and there are 3 more 10-cent coins and 5-cent coins. Yeah, we can have one for 5-cent coins. So F. But then we know that he has 3 more 10-cent coins. So there's just F plus 3 10-cent coins. And for 25-cent coins, we don't know. So we'll just let that be Q. And then we also know the total value is 320 cents. And that sets up on other equations. So we have 2 equations and 2 variables. And that should make it easier to solve than having 3 variables. Okay. No change. Okay. Great. Everyone got it. 2 questions left. Okay. So that's interesting. Keep in mind that it says how much time will it take them to put all 30 toys into the box for the first time. So that happens when Mia's mom manages to put 30 toys into the box. Even if Mia takes 2 toys out of the box. So um the first time that they have 30 toys in the box is not like the time when they actually, yeah, for the first time. Yeah. So yeah, be careful with word problems. Sometimes they can have stuff like that and trip you up. Yeah, and it said minutes, not seconds. The MAA likes to do stuff like that to trip you up. So
Nice,
be
Richard,
careful.
for getting that correct.
Okay, last question. Okay. So which ones are the frogs? Right, so Chris or Leroy, one of them is a frog, but not the other one. And then Brian and Mike must be must both be frogs. And usually with like logic problems like this, you can um just assume that one statement is true and see if the others make sense, or assume it's false and see if the others make sense. This one is, you can look at the fact that both Brian and Mike are like related to each other, and Chris and Leroy are related to each other. So you can do those two independently. All right, final leaderboard. Okay, congrats.
Nice.
All right. So that's the end of this meeting. Um, we hope you enjoyed. First, before you guys leave, it would be great if you could like provide some feedback on the problems today. Were they too easy or too hard? Um,
And then also feedback on how we're doing.
yeah, and like if you like this format or not, or if you have any suggestions for other possible activities. Yeah, and you guys are free to go, but if you want to stay around and work on some of the more of the problems, or have any other questions, feel free to do so. But thank you for coming. Hope you enjoyed.
Just silence.
Okay. Do you guys have any questions or anything you want to work on right now, or